Hello again, welcome to another lesson in geometry. Today we are covering section 7-3, proving triangles similar. All right, so if the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. And we want to write the converse of this theorem. So remember, the converse is to flip around the hypothesis and conclusion. So we're going to say, if the parallelogram is a rhombus, then the diagonals are perpendicular. Diagonals are perpendicular. All right, and our second one, if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. And if we do the converse, then we would say this: if a point is equidistant from the endpoints of the segment, okay, then it is on the perpendicular bisector. Of the segment. All right, so remember, just flip the hypothesis and conclusion to do a converse. All right. Vocabulary builder, we have verify. So verify in a related word is a proof. Okay, that's a noun. And definition, to verify something means to find the truth or accuracy of it. And our math usage is a proof is a way to verify a conjecture or a statement. Okay. So write true or false for each statement here. You can verify that two triangles are similar by showing their corresponding angles are proportional. And this is false. Remember, the angles have to be congruent and the sides have to be proportional. Number 4, you can use properties, postulates, and previously known theorems to verify steps in a proof. And this is true. This is how we go about proving something in geometry. Okay, on the top of page 2, we have 3 shortcuts to prove two triangles are similar. So normally, to prove two triangles are similar, we'd have to prove that all the corresponding sides are proportional, okay, and that all of the corresponding angles are congruent. So we have 3 shortcuts here that will help us do a little bit faster. And these only work for triangles. So our first one is angle-angle similarity. So that just says, hey, if 2 of the angles are the same, for instance, maybe you have a 90 and a 30 here, and then you have another triangle that has a 90 and a 30, then those 2 triangles would be similar. All right, our second one has side angle side similarity. Okay, so it says, hey, if you have one angle that's the same, and only one, we can still prove it if we know something about the sides. All right, so here's 2 triangles, and we could say, oh, these 2 angles are the same. Okay, and then we can, well, look at the sides around those angles. So maybe this is a 1, and this is a 3. And this is a 4, then this ratio of the short ones is 1 to 3, so this would have to be a 12. So if the sides are proportional that surround that angle, in this case both of ours have a ratio of 1 to 3, then we know the triangles are similar. And then lastly, we could just look at all the sides. So if all of the sides are proportional, so the small divided by the small and the big divided by the big and the medium divided by the medium all made the same number, then we could say that the 2 triangles are similar also. All right, so looking at these 2 triangles, could we prove they are similar? And this would be yes. So we do have an angle in between 2 sides. And let's look at the big ones compared. So the big one divided by the other big one would be 2. And then the small one divided by the other small one would also be 2. Notice we're taking the big triangle divided by the little triangle also. Okay, so this is the big sides of the big triangle divided by the big side of the little triangle. And down here, this is the little side of the big triangle divided by the little side of the little triangle. And in both cases, we kept getting 2, so the sides are proportional. So this would be yes, SAS. Okay. Similarity, not SAS congruence. All right, so use angle-angle similarity postulate. Are the 2 triangles similar? How do you know? All right, so we'll complete the diagram. We want to fill in the missing angles here. So we have a 90, we have a 39. We could subtract from 180, and that would leave us a 51 right here. And then our other triangle, we have a 90 and a 51, and if we subtracted those from 180, that would leave us with 39. So these are going to be similar because all the angles are the same, and two triangles are similar as long as two of the angles match. So this would be yes. We have two pairs of congruent angles. Okay, we actually have all three, but all we need is two, so we could use a similarity to prove that the triangles are similar. Okay. All right, problem number 2, verifying triangle similarity. Are the triangles similar? If so, write a similarity statement for the triangles and explain how you know the triangles are similar. So we're going to write the three ratios, and we're going to do the big one to the little one. Okay, so the big triangle is EGF and the little one is ABC. And let's compare the sides. So for the big sides in the big triangle, that's EF. And the big side in the little triangle is AB. And if we compared their numbers here, that's 12 to 9, which reduces to, let's see, 3 divides into both of those, so 4/3. Okay. And then the two little sides in both triangles, they're the same, but we'll have to do them separately here. So in the big triangle, we have G to F, and that's going to be the same as A to C. Okay. And that's going to be 8/6. G to F is 8. A to C is 6. And if we reduce that, we still get 4/3. So far, we're good. And we know the other one's going to be the same because it's still going to be an 8 and a 6. So we're going to compare G to E to BC, and that's going to be 8 to 6 for 4/3 also. 8 to 6 there. So since all of them are the same, we could do side similarity. All three sides are proportional, so no matter what pair of sides we compare, we always get 4/3. And that means triangle ABC is the same as triangle EFG. All right, let's flip it over and take a look at page 3. Okay, problem 3 on page 3, we have proving triangles similar. And we're given two parallel sides here. So AC and PM are supposed to be parallel. And we want to prove that the little triangle ABC is similar to the big triangle PBM. All right. And we're given the reasons for this. We just have to get them in the right order. So AC is parallel to MP. Well, that's going to be our given. Okay. And then we have angle A is congruent to angle P. So these two angles are supposed to be congruent. If we look at our parallel lines, then that's going to be alternate interior angles. And if lines are parallel, then we always know alternate interior angles are congruent. So they wrote, if parallel lines are cut by transversal, alternate interior angles are congruent. And it's the alternate interior angles theorem. Okay. All right, then we have triangle ABC is congruent to triangle PBM. I'm sorry, not triangle, but angle. And our angles are congruent, these two angles, because let's see, these are vertical angles. All right, so we would do this. Vertical angles are congruent. And then the two triangles are going to be similar, and it's easy to tell now because we have two sets of congruent angles in each triangle. So this is going to be by our angle similarity postulate. All right. Problem number 4, finding the links in similar triangles. So we have a picture here. There's a climber here. He wants to figure out how tall he has to climb up this cliff here. So what he does is he walks backwards. He puts a little mirror here. He lines it up so that when he looks in the mirror, he can see the top of the cliff. And then he uses the height of his eyeballs, where he is looking in the mirror, and then the distance he is from the mirror, and the distance the mirror is from the cliff to make similar triangles and find out the height. Okay, so why does the ground have to be level? Well, that's important because we're not going to get it right if he doesn't have level ground. Let's see why. So if the ground is not flat, HTV and JSV will be right angles. And this is no. Definitely we're not going to get right angles if the ground's not flat. If the ground's not flat, then this angle down here is either going to be smaller or bigger, and so will the other one. So if the ground is not flat, you will be able to find congruent angles. So if the ground is not flat, what they're saying is these two angles here will not be the same. Okay? All right? So you will be able to find congruent angles is no, we can't find those. Okay, so why is it important the ground be flat? So we have to explain this. So you might say something like, if the ground is flat, then we'd have HTV angle and angle JSV will be right angles. Okay. And HVT and JVS will be congruent. If that's not the case, then we don't have similarity between the two triangles. Therefore, we can't use the similar triangles to find the missing piece of our proportion here. Okay? So we need the ground to really be flat here. Now, if it's just a little sloped, you could still do it and get pretty close to the answer. It just won't be perfect. Okay? All right, let's flip it over. So on the last page here, we have a lesson check. As always, pause the video, try it yourself, and then come back and see if you knew what you were doing. Okay, welcome back. All right, so for our lesson check, we have an error analysis here. We have two people trying to find the missing side in this triangle here, this X. And you can tell that the triangles are similar. So the little triangle on the left is similar to the big triangle on the right. And we can use angle similarity to show that. We already have one set of given angles here. And we could use vertical angles to get the other set. Okay. So one of these people did it wrong and one of these people did it right. We have to figure out which one. So it says number 15 here, write the side lengths of the triangles. So the shortest side in the larger triangle is 6, and the shortest side in the smaller triangle is 4. Okay. The longest side in the larger triangle is X. That's the one that touches the one angle but not the two angle. And the longest side in the smaller triangle is 8. Okay. And then the medium one, or the third side here, is going to be 9 in the big triangle on the right and 6 in the little triangle on the left. Okay. Write the ratios to compare the lengths of the corresponding sides. So the shortest side's ratio is going to be 6:4. The longest side ratio is x:8. And the third side, or the medium side, is 9:6. Okay. Cross out the proportion that does not show the ratios of the corresponding sides. So 9/6 to 6:4, that one's fine. 9/4, I don't have any 9/4 in here, and x/8, so this one's probably going to go away. X/8 and 6⁴, that's here and here, so that's good. And x/8 and 9:6, that's here and here, so that's good. Okay. All right, so cross out the solution does not show ratios of corresponding sides correctly from above. So let's think about this for a second. All of these proportions here, if we solve them, we're going to get 12 here. So this is 4x equals 48. So x would be 12 in this one. This guy is 6x equals 72. So x would be 12 in that one. And this one I can't solve, but we get 36 as 36. So let's go back up here and take a look at these and see which one is solved correctly for 12. Well, B is the correct one. So what did they do wrong in A? So in A, they did 4 to 8. Okay, so this 4 and 8. So 4 and 8 were both in the small triangle. That can be okay as long as you get the right things from the big triangle. And in the big triangle, they used 8 and x. Oh, they used the same thing from the small one. So they used stuff from the small one twice. So this is just not going to work. All right. So solution A is bad. Explain why the solution you crossed out does not show the correct value of x. You could say something like they didn't do the ratio of the corresponding sides correctly. So A does not show the ratio of the corresponding sides correctly. All right, so this concludes our notes today. You should be pretty good with indirect measurement, which just means finding the extra side, given that the triangles are similar, and similar triangles, and somewhere in here. And if you take a look back at here, this is a pretty common word problem here. We didn't actually solve this, so you might want to think about how could you find that x? Which sides would you make for your proportion to go together? All right, I'm sure we'll be doing something like that in our classwork next time.